Welcome to the Node.js and Oracle Database Office Hours for July 2020. Thank you for joining. Then a safe harbor statement. Everything we say is subject to change, particularly in the open source world. We tend to go on very short-term notice on demand, so don't hold us to anything we say. So on the call, we have myself, Christopher Jones, product manager in the database access team, looking after scripting languages and bits of SQLnet and Instant Client and other sort of client-side tooling. Anthony Tuininga, lead developer here for a number of our database access APIs, creator and maintainer of the Python 6 Oracle driver, now doing most of the work on the node-oracledb driver, working on some of our contributions for the Go driver, ODPI-C, which is our C interface, a bunch of other things there, internal, external as well. So we've got some good skills here online. So today, just wanted to talk about node-oracledb 5.0, which has been released. It's now available on NPM. Thank you to everyone who has contributed. Our testing team, lots of tests going on there at stress level and functional tests, docs being written, code's being written, modernized in this particular version. Lots of new features, and I'm just going to highlight a few here in this session and let you explore the others by looking at the changelog and installing and playing with it, reading the updated documentation. So a couple of the features I did want to highlight in case you haven't caught up. We now have database startup and shutdown methods. I'm not going to show any of that. I do have a few slides for some of the other things and then also some demos. So I'll show some demos as well. Database startup and shutdown, relatively specialist area. But it can be useful. A couple of variants on the API there for startup and shutdown. There's a sort of simple way because most of you just want to start up or shut down. Other people want to be able to do more control on the database. You may remember it has like a mount phase, startup, no mount, startup, mount. Lets you do recovery and things. So there's a more complex API as well if you want to play around with all of those at the various stages of the startup. And then you have more control and have to do more steps to start up if you do the more complex one. Simple one's pretty easy to use. Check the doc on that. I mentioned modernizing the code base, so we refactored the JavaScript layer in the driver, in the module, to be following the async await style. That meant we removed support for custom promise libraries. Apologies for anybody who was using Bluebird or anything like that. Pretty sure most of you using something like that are going to be not upgrading anyway to the new version of the driver, or you can just cut over to the standard Node promise library, which has been around for a number of versions now in Node.js itself. Pool attribute Qmax, I've got some slides on that, bit of a pool refresher, talk about that, nested cursors. I do have a demo, although it's not that exciting. Yes, we have support for nested cursors, but at least you'll see the demo if you're not sure what one is. New initialization functions, I'll go through that, and prefetching, also a bit of a refresher in terms of query fetch performance tuning. So I've got some demos there coming up. And of course, towards the end, once I've finished my little bit, feel free to ask a question, stick up your hand, and just let us know in the chat if you have anything you want to ask about anything I've covered or haven't covered, and obviously let us know what you want to be covered in future. So I'm going to talk about connection pool. This is really in guise of that Qmax parameter that I mentioned was new, but a couple of slides here to give you a bit of a refresher on the pool behavior may help explain what's going on. We have a connection pool. We recommend using a connection pool for a number of reasons. One is it provides a lot of the high availability features of Oracle database, failover, application continuity, a couple of buzzwords you may know about. It also does some lower level, simpler things like socket checks and whatever to make sure that whenever your application asks for a connection, the connection is immediately available. Has performance benefits here. The pool's been started. So it's got a min size, I guess there are four connections have been opened to the database. Those connections are established, and therefore the application can use them immediately with no extra overheads of starting up the processes which is running on the database side, or the pool maintenance on the connection maintenance on the Node app tier itself. So one thing that the real world performance tuning group in Oracle always recommend is having a fixed pool size. Doesn't always work for everybody, but if you can, kind of recommend it ourselves. It means, as you can see here, that all those connections are opened up front. It means if the database can't handle that load, you're going to get an error at startup, you're going to be able to fix it. Rather than if the pool grows and shrinks, if the pool grows but the database can't handle it, your app's in the middle of running, users are trying to connect, something's going to fall over at runtime. That's not so useful. Also, having a fixed pool size means that you avoid connection storms. So everybody coming in the morning, trying to do work. So some people already got connections, they're trying to load the database with their queries. Other people are trying to open connections, so the database is doing a lot of extra overhead at that time. So fixed pool sizes generally recommended where they work for you. And along with that, try and stop the firewalls from closing idle connections overnight and DBAs from imposing resource manager profiles and closing unused connections as well. You want that connection pool to be available at any time, certainly at those peak periods in the morning, or if you're doing bigger processing, whenever. So the major parameters there are the pool mean, pool max, and the pool increment. And if you follow my guidance, then you set pool mean and pool max to be the same, pool increment to be 0. Don't forget, if you're bumping pool max to bigger values, you need to bump the number of threads available to nodes so you don't get thread starvation. There's a parameter for that, UV thread pool size. Look in the doc for that. And the other tip is don't oversize connection pools. We got some monitoring capabilities, a log stats feature. Go and look at that, see how your connection pool is being used, try and keep it as small as possible. It's a pool, it's a shared resource. You don't want to be using, having extra pool overhead if unnecessarily. Don't want to be overloading the database with those extra connections if you don't need them. So that's a refresher into sort of pools itself. So let's say you've got a few users, your users come in, you've got 3 users, so the 3 of those connections are being used, everything's going fine, that's kind of nice. What happens then when you have a bunch of extra users? We have this connection queue, which is always enabled in the driver. And so those extra users, once all of those 4 connections in the connection pool are in use, those extra users are going to be staged. When they do a get connection, when you do a pool.get connection, they're going to be staged in this connection queue, not doing any work, just waiting. No, nothing's going to be returning to that user. They'll have done the get connection call and it won't have returned. That connection queue by default just grows infinitely, and it does have a timeout. So queue timeout, the default is whatever it is, 60 seconds, I guess. And if a connection in the pool has not been freed up, and so something can't move from the queue to the pool, then the user who did the get connection is going to get an error at the NJS 040, say, hey, you waited in the pool for a connection for 60 seconds, sorry, couldn't be satisfied. Fail, can't do any work for you. And typically we see that error if people haven't set that thread pool size high enough. And so you get some sort of thread starvation going on. One of the issues with this is that the pool can grow infinitely. People aren't going to wait 60 seconds. They're going to be hitting reload. You're going to get new connection requests coming to that pool queue, into the queue, and just generally going to overload the system. Very good ways to get around that by using your own technology, load balancers, etc. But that's a slightly heavier weight solution. If you want a lightweight solution, we've stuck that into node-oracledb 5, which is this kind of Qmax. So Qmax is a limit. It's 500 by default, so the connection queue will never exceed 500 waiting unsatisfied connection requests. If the 501th request comes in, they'll get an immediate error without waiting for that timeout. So get the NJS 076, the new error. And you can size the pool, you can size the queue, you can set the queue to 0 if you don't want anybody to wait, or you can set it Qmax to a -1, which means the old behavior, just infinite waiting. But hopefully this will just save a couple of people there. And I expect we'll see a few NJS 76s instead of the NJS 040s when people haven't sized their UV thread pool size correctly. So that's a little bit of a refresher on pooling. Fixed pool sizes are generally good. Got a couple of parameters to control the behavior so you can bound your quality of service that you want to satisfy with your applications and make your customers happy. So what else is new? And I'm going to have a couple of demos on this, and I've got some more slides following this. This is the hand waving overview. It is a new option called prefetchRows. It is a fetch tuning parameter. So it's not for tuning SQL queries, the execution of. It's tuning the getting of the rows returned from the database into node-oracledb. And it works in conjunction with the existing fetchArraySize parameter. So these two parameters don't affect how the application actually receive rows. If you're doing query stream, if you're doing get rows, if you're just getting all of the rows back anyway as one big array just from a straight execute, you're still going to get the same number of rows, the same time you're going to get those. It's not going to change. It's just to do with the internal buffering and the flow control across to the database. So one of the big premises for Oracle Database is, where's my little laser pointer? There we go. One of the big things in Oracle Database is to try and reduce what we call the round trips, so the trips between database and node-oracledb. And you kind of want to do that because that means the database doesn't have to wake up as often. You can handle more people, more other users connected into the database and handle their interrupts, handle the network traffic, so there's lower traffic across the network as well. Now that sometimes may mean you get a little bit slower performance at this end, and I'll go into that later, but overall your system will be more scalable because you have to be able to have more load on the system. And you probably read ahead there in terms of the execute fetch calls. Let me just go and run ahead and do that in a bit of slide work. So we have what we call the array fetch buffer and the prefetch buffer. They're two buffers allocated, and their size will depend on the values you set. You would have seen the prefetch buffer would be big enough to handle 2 rows, and the fetchArraySize, the array fetch buffer will be big enough to handle 100 by default. What happens when you do an execute of a statement is the statement obviously has to go across to the database. So this is queries only. And Oracle has that distinct execute and fetch phases because not all statements are queries. They could be executing an update statement. So we send across a statement. Generally, you get back a message that says, okay, the statement executed successfully. And then the application has to come into a fetch and gets data. Now, prefetching is a way for the data to come back originally with the OK success message from the query itself. So one round trip to the database actually returns data, even though the application at the internal layers hasn't really said, give me any data yet. So kind of talking internals, but that's the execute stage. We prefetching rows into that prefetch buffer. And this is handled by the Oracle Client library, so Node doesn't know a lot about it at this stage. What then, of course, happens is that those rows, that data gets copied into Node Oracle database space and then back to the application. And so that would be the second phase. But there's no extra data copies across to the network. Yes, there's a data copy across between these boundaries. And this is the key thing, that you've reduced perhaps the number of times you've gone to the database for data, but you've got an extra copy across this boundary. So you're kind of balancing the fact you've had memory allocated, chunks of memory allocated versus network costs here. Okay, so if you had a big query which needed lots and lots of rows, you might then actually need more round trips to the database. And at this stage, you wouldn't be prefetching because prefetching is only at the lower level execute phase. This is now the sort of fetch phase, the lower level fetch phase. And when the request goes across, obviously everything's literally going across through the client library stack. The memory that the rows, extra rows comes back into is actually in the Node Oracle database space. So there's no extra memory copy across a boundary. So that's a little bit of hand waving about prefetching and array size. Key points there, as I mentioned, that you've got this extra memory copy across the boundary, but you're reducing round trips. So you're trying to balance memory and network performance. Let me go into a little bit of demo and talk about some of these things, including the initialization, which actually I will do first, if you'll forgive me jumping away from prefetching for a minute and then coming back. So I've got a few scripts here. Oops. My keyboard's not set up. Okay, initialization. So I mentioned we have a new initialization function, initOracleClient, and this is particularly useful on Mac and Windows. Can be used on Linux, but you still on Linux need to set library search path either with ld-config or ld_library_path itself before you start the application. That's an issue with the Oracle Client libraries. Yes, we're trying to see if we can resolve that. Bunch of issues in terms of patching and libraries and linking and exposure of symbols and all sorts of interesting little bits and pieces there, which even I don't know all the details of. So let me run this anyway. So this is Node, and what's going to happen is I'm going to get an error some of you may have hit before. DPI 1047 can't open this library. that's looking for. So on people not familiar with Mac, that's the Oracle Client shared library there, the dylib. So unfortunately, Apple has been tightening down on third-party library use. Recent Node.js binaries have made changes. So on older versions of Mac, even current people keeping up to date with Node have been affected. And then the new latest version of Mac, the version they call Catalina, has also tightened things down, which has caused even more problems. So if you're a Catalina user, you will need to go into your system preferences into the security pane once you try to run Node. It'll say, do you want to authorize, a particular library, this client SSH dylib library, have to authorize that, and then it'll probably ask you a couple of other libraries that sub-libraries that then get loaded. So you need to go into the system library search pane on macOS and authorize those. That actually won't immediately help this because we still haven't actually found these libraries yet. But you will need to do that as part of the whole process. So let's have a look at the application. So you can do something similar on Windows, and I'm just going to link, which is effectively copying that client shared library into my node_modules subdirectory, and this is actually where the binary is stored. Let me just go and do that. And then if I run my application, and it's going to go across network to remote database, which I set up so I can show you the prefetching later. You can see that everything works, and that's kind of nice. What you can see here is that I have the node modules directory I mentioned. I have all the binaries for each of the platforms. This just gets part of the standard install when I did the npm install. But I now have in this case, it's a symbolic link. If you're copying libraries, you need to copy just more than this as well. There are a couple of other libraries you need to copy, and same under Windows as well. But that's just a quick, handy way. Let me just go back and tidy up. I just showed you that ls. Delete that link. And the other way, which actually does the same thing as create this link, you could probably do a copy on Windows. If you want to bundle everything up to make a distributed package, as I said, you probably have to copy more than just this package. But here, post-install in my standard package.json would have done exactly what I did in the manual step. The other way is to copy or link. Again, I'm copying here on macOS into the user local lib directory, and I can again run the file. So that may be a convenient way if you just want to stick everything there, then you don't have to worry about every time you regenerate your node modules directory having to update the symbolic link. So that's one other way on Mac. And once you've done one of these, as I say, on Catalina, on that new version of macOS, you'll get some errors. You need to go into that system security pane now that it knows that it's actually looking for these particular libraries and authorize them. The other way is this new funky method called initOracleClient, and it has a couple of options. I'll let you read about those in the manual. You can specify the location of the optional SQLnet files if you're using a tnsnames.ora file as well. And you could also customize a couple of error messages if there are errors and issues actually loading the client libraries. But this is a kind of interesting way. This, you can see this is going to reference $home, and in my $home I have my unzipped instant client. And again, as you'd expect, everything works nicely. Quite often, I just have an if, which sort of says if the system is a Darwin architecture, then I run this. And then obviously my script becomes portable across other platforms, or relatively portable. So this can be useful. Bottom line, we have this new method which can be useful, so you don't need to fiddle things at the operating system on Windows or Mac OS. Some fine print about how it's sort of more beneficial perhaps than deferring the loading of the library, which would otherwise happen at point of first use. But all of that's in the documentation, so let's not repeat that here. So the other feature I wanted to show you was just nested cursors. So for those who have not used nested cursors, this is a nested cursor, doing a select and then getting effectively a subselect back as part of the data. Let me just split the screen, and in the bottom I'll execute that. and you'll get the fairly standard expected output. Now here I am just fetching, not saying result sets, I'm just getting all the data back, getting it in the object format. I can obviously get it as the array format as well, which by the way is slightly more efficient, so it does have some performance benefits. One other tip about nested cursors is if you are fetching them as result sets, then you need to make sure that you close each of the subcursors, otherwise they won't get closed until the end of the connection and your memory use will just keep growing up. So it's one of those things you probably won't even notice, it just works when you want it to work. Okay, back to round trips. So I have an application, and a lot of this is actually, by the way, in the documentation. So this is a script which is going to show you, as you can see down in the output here, just going to show you how many rows, the values, the parameters, how many round trips it took to go between the database and node to get that data, and obviously the time. How do I calculate round trips? And this bit is in the node-oracledb doc. One thing is I need to use a second connection, so I need a system connection to monitor the first connection, because otherwise, every time I try and do a query on the first connection, the round trip value is going to bump up. So I need to get the session identifier of my standard connection. And then a second system connection, I'm going to use that system identifier, look at the stats tables, and just return the number, which is the number of round trips. And I can take a snapshot before and after and get the elapsed time and the elapsed number of round trips before, time before, and calculate the round trips difference, and then obviously the time difference. So I can play by adjusting with these couple of values, the round trips and the time. Now this is a relatively small table. Employees has only got just over 100 rows, so it is useful, but the times may not be always as linear as you might like. So if I just run this, these are the default values, 102. Now there are 107 rows in the employees table, just that's the way it is. It took 3 round trips, so 3 trips across to the database. And all that stuff I kind of confuse you with about prefetching, array fetching. You almost don't have to worry about that. Just focus on the round trips, focus on your metrics, focus on the database system load. Do what's best for your system. Obviously, you don't want this to be a huge number if you've got a small table. But we can play with this and have a look. What happens if we set this to 100? Round trips has dropped, so databases had to do less. Lapse time has actually in this case also dropped, so that's good. If we set these to 200 each, wow, 1 round trip, and then the time dropped even further. Now, you may not see the time always drop, because as I mentioned before, we've got this extra memory copy across the boundary, but because there are fewer round trips, then your system may be more scalable overall. You may have better system performance, system behavior. So you kind of need to do some tuning first in your development environment to reduce round trips, and then maybe in the system environment to work out what actually is best overall for you. Now, I have a couple of scenarios I'll show you in, actually let me pop that up and I can come back and we can do the demo. So how do you choose these values? They're sort of starting points for tuning that I'm going with. I won't run this, I don't even have this table created, so it just errors out. But if you've got some big table, you're doing some big data streaming, you would probably set fetchArraySize and prefetchRows to some equally big values. It could be 5,000, supersized, maybe 10,000, whatever works for you. You would probably set those to about the same values. If you're paging data, so here I'm only going to fetch 20 rows, and I may be getting 20, then another 20, then another 20. You want to keep fetchArraySize, the same, pretty much the same value, because although that will reduce memory copies across the boundary. But the interesting thing here is I set prefetchRows to 1 greater, and Y is all buried into lower levels, and I've complained about it myself, but it's all to do with detecting end of fetch. I'll come back and show you this in that app in a minute. So this will do 1 round trip just to get all of these rows. If I set this to 20, you'll see that it would still take 2 round trips. Single row fetches, or very small rows, you might set fetchArraySize to 1, because then you don't have to allocate. That's a bit confusing, but that's obviously just fetching a single row, not 100. You would try and reduce the memory sizes which need to be allocated across the stack. Yes, maybe it's better for the memory allocator if every query allocates exactly the same chunks of memory. Again, you're tuning that to your application behaviors. Don't do any premature optimization. Let's go back to this 3 case, and actually I'll split the screen again. And let's have a look. So we know we've got 107 rows, so pretend we want a page of 107 rows of data on our screen. And as you saw, I needed to set this +1, so let's not set it to +1 at the moment. Let's run it at the bottom. And you can see I'm doing 2 round trips. So it's when I set it to that +1 to avoid the end of fetch detection, that's where we actually avoided that round trip. And this is going across to my database, which is in my office. I'm sitting at home, so it's a relatively far distant, slow network. And that's it for the new features. Tune these values, tune them in your dev environment, and then fine-tune them in your production environment. And make sure you let us know how you're going with the new features, and obviously any issues that you have, yell out on the GitHub issues list. So that's been about the half hour. I will go back to slides, and we can open up for questions. And if anybody has anything, then let us know. Otherwise, we'll call it a day, and you can rewatch the video and understand a little bit more about prefetching by testing it out yourself. Thank you very much for attending the Node.js and Oracle Database Office Hours for July 2020. We will see you in a couple of months. Bye-bye, everyone.